a camera lens has a focal point of 2 centimeters. Draw a diagram to illustrate the meaning of this statement. Now, what they're really looking for here, it's hard to know sometimes. What they're really looking for here is for you to draw yourself an axis and to draw a lens in the middle of it. And then have 2 parallel rays of light hitting the lens like that, coming from a distance, and then them both passing through the same point on the other side, and that's your focal length or your focal point there. So if I just draw that in here, we'll get you straightened up here, something like that, and like that. And we'll put arrows on them then. So arrows for the light coming in through and coming through here. It says draw a diagram to illustrate the meaning of this statement, and so you have to put in 2 centimeters here, or you could put F in there or label it focal length. So it says F marked, so we'll put an F in here and 2 rays, and if you're 2 centimeters you'll be fine there, either that or the F and your 2 rays. Last question. The camera is used to photograph an object O, which is 3 centimeters high and is placed 6 centimeters from the camera lens as shown in the diagram below. Mark and label on a full scale diagram the positions of the 2 focal lengths or points of the lens. So it says this camera is used to photograph an object which is 3 centimeters high and is placed 6 centimeters from the camera lens as shown in the diagram. To mark the position of the 2 focal points, what you have to do is make sure that you first of all draw so what you have to do is mark in the 2 centimeters from the last part of the question over the page, and that is here. Mark an F here and an F here. Then it says, using a ruler, draw rays on the diagram to show the position and the size of the image. Mark and label the image formed and put arrows on the rays to show their directions. So what I'm going to do is I'm going to continue my diagram here and just finish it off. So you've got a ray which goes right down through the centre of the lens. And the centre of the lens is always where the 2 axes cross each other. And then a second ray is going to go parallel to the axis, the principal axis, and down through F, and it's going to go something like that. And so the image is going to be about here, just beyond that place there. Again, I would have this much more accurate if I was using a nice sharp pencil. It's not too straight looking there. So that's the image. I know that it's upside down because this ray of light here coming from the top of the object is going to pass through the top of the image, and so therefore my arrow has to point down to the top of the image, and therefore the thing's upside down, the image is upside down. So you are going to get marks for putting arrows in this, of course, and you'll have a mark for this correct continued ray, you'll have a mark for this one correctly continued, you'll have a mark for showing where they meet, you'll have a mark for marking your image, and I'll mark it with an eye here, and you'll have a mark for your arrows, and that gets you your 5 marks. It then says what type of image is formed in this case, and it's a real image because it can be captured on a screen. The diagram is full scale. How far from the lens should the film be so as to produce a sharp image? And so if you want to get a sharp image, you will have to place your screen there. And so you just have to measure that. So it's, from my diagram there, it's just beyond 3 centimeters, and I'm going to write it down as 3.1. And again, it would probably be a little bit more accurate if I'd used a nice sharp pencil. And the last question, how tall is the image? And so the image there is just over, it's just about 1.5 centimeters on my diagram. Now they will give you a margin of error here, plus or minus 0.1 or 0.2. And that's the end of the light questions.